Hello, welcome to Electronics Education. This is Vincent Chang. In this lecture, we are going to study an operational amplifier as instrumentation amplifier. Operational amplifier as instrumentation amplifier. In the previous lecture video, you have learned this is the conditional differential amplifier. What's the condition? When this relationship is, the criteria is met, only when this equation is met, the criteria is met, can this circuit becomes a differential amplifier. And what about the trade-off? The second takeaway from the previous lecture. You can have both, because on the left hand side you see the differential gain. On the right hand side you see the input impedance, input resistance. So high input resistance and high differential gain, you can have both. You have to sacrifice one way or the other. So there's a trade-off between the input resistance and the differential gain. So for instrumentation amplifier, the circuit we're going to study in this lecture video, on the right hand side is the same circuit. But if this is the differential, yes, it's differential, right? So R3 equals R1, R4 equals R2. So it's the differential, because the differential criteria has been met. But you add the preamplifier, the buffer stage, which is composed of the two operational amplifiers and the three resistors. The buffer, this is the whole structure, the whole diagram of the instrumentation amplifier. So two-stage. So it's the two-stage amplifier. The first stage is buffer. The second stage is the differential. The first question, what about the input differential resistance in this case? What's the current flowing in to the first op-amp? What about the input current flowing out of the second input op-amp? Both are zero, right? So infinite. So it's the infinite input resistance. It's the infinite input resistance. So the problem of trade-off, the problem of sacrifice has been solved. But what about the gain relationship? The relationship between the single-ended out and the differential in. Let's start with the second stage, because it's the differential, so VO equals negative R2 over R1 times VO1 minus VO2. For the circuit analysis, then, can you follow this? Because the voltage difference between the VO1 and the VO2 equals what? Kickoff voltage low, KVL. The addition, the sum of the three dropped. The first dropped IRB, second IRA, the third IRB, BAB. So orange comes from the orange. Orange on the left is replaced by the orange on the right. So you have to sub the current I. The I, Ohm's law, it's easy. Virtual short, you apply virtual short for the first op-amp, and virtual short, another virtual short for the second op-amp. The Ohm's law, the I equals Ohm's law. So here's the outcome. This is the outcome. So what's the gain? What's the gain? The negative R2 over R1 times the 1 plus 2B over A. High differential gain and high input resistance, you can have both. But usually, the RA is off-chip. And the R band, the 3 R band, and the B, and the 1, and the 2 are on-chip. Let me show you a commercial example. This is a commercial instrumentation amplifier from Elliott Sound Products. Okay, so you see the box. The instrumentation amplifier, that's the on-chip part. So see the 10 kilo ohm, you have to pay attention. This is different from what this is kind of flip. All right, so negative feedback is on the bottom. So ratio, the relationship, differential. And then the RB, which is 10K in this case, is on-chip. But there's the off-chip resistor called RG, associated with the RA in the previous slide. Commercial instrumentation amplifier. So using the off-chip, you can tuning the off-chip resistance RG, you can tune the gain, the differential gain. Here's the takeaway. High performance differential amplifier called instrumentation amplifier. 2 stages. The second stage, differential. The first stage, buffer. High input resistance, very high input resistance, and differential gain usually is adjusted, moderated by an off-chip resistance RA. This is the end of the lecture video. I hope you learned something from this lecture and connecting the learning with the previous lecture, op-amp as the differential amplifier. Thanks for watching.